Hi, welcome back, Hananiga, Algebra 1. Today we're going to do sections 8.1 and 8.2, and your homework assignment will be a worksheet. So let's start with the vocabulary. What is a quadratic function? Well, it's a nonlinear, so it's not a line. So it's nonlinear. It's a polynomial with degree 2. So basically, it's got an x squared in it. And you can actually have a y squared. That would be something you talk about a little bit in Algebra 2. But for right now, we're going to be graphing only an x squared. So it's a parabola. Now, the parabola is technically the graph of a quadratic function. So when you have a quadratic function, you're asked to graph it. It makes like a U shape graph. But that is a parabola. All right, the parent function of a quadratic, the most basic quadratic is y equals x squared. Anything you do from there basically is a transformation of some type, whether you do a vertical stretch, whether you do a vertical shrink, whether you do a translation left, a translation right, whether you do a reflection on the x-axis. Again, all of those are just changing the parent function. So let's a couple of terminology here that I want to make sure we talk about. The lowest or highest point, the very bottom or the very top, depending on which way you want to look at it, and I'm going to make it red here so you can see it a little better, is what's called the vertex. So the vertex is a point. That is the main thing I want to make sure you guys understand. The vertex is a point, and it's the highest and or lowest point. The axis of symmetry, when I draw a line and I cut it symmetrically, meaning right down the middle through the vertex, that line is known as the axis of symmetry line. So in this case, in this picture, we have a vertex at 0, 0, and we have an axis of symmetry at x equals 0. So notice when you write your equation for your axis of symmetry, it's a line. And when you write your answer for a vertex, it's a point. So I'm stressing those two pieces of information. Okay, and yes, you will need to have the whole x equals part as we go along here. So let's do the parent function. Off to the right-hand side, I want to graph y equals x squared. So just to remind ourselves of the previous picture, so if I put 0 in for x, I get 0. If I put 1 in for x, I get 1 squared, which is 1. 2 in for x, I get 4. Now, because you're squaring something, negative 1 squared is also 1, and negative 2 squared is also 4. So 3 squared would be 9, and negative 3 squared would be 9. So notice it's symmetrical on either side. So whatever answer you get on the right-hand side of the vertex is the same answer you'll get on the left-hand side of the vertex. So that is the parent function. Now I want to do a new one here, and they didn't give me a lot of space. I'm going to do an XY chart for y equals 2x squared. So I'm going to do an XY chart. And because I don't have a lot of space, I'll just make two XY charts. So I want to find 2 and 1 and 0 and negative 1 and negative 2. So I'm going to plug each one of those in for x. So if I plug 2 in, 2 squared, which is 4, times 2 would be 8. 1 squared times 2 would be 2. 0 squared, so I get 0, 0. Now, remember when you square things, you get the same answer. So negative 1 squared is 1. It's always positive. Negative 1 times negative 1 times 2. And negative 2 squared is 4 times 2. So I'm going to graph those points over here. 0, 0. So notice it's got the same vertex as the parent function. 1, 2, 2, 8. Well, you'll notice comparatively with the parent function. So when I'm looking at this one and I'm looking at the parent function, actually, let's get to that in just a minute. I'm going to go ahead and answer the questions. Vertex, 0, 0. Axis of symmetry line. It's always the x value of the vertex, by the way. So it's x equals 0 in this case. Because remember, if I drew in a vertical line that cut through the parabola in half, And you don't have to actually draw that line in, but it will always go through the vertex. And because we're dealing with only up and down parabolas, it's always through the x value of the vertex. Now, the y-intercept is not a point that I am very concerned about. It's just literally a point. So looking at the picture, where does it touch the y-axis? Or if I plug 0 in for x. Domain. Domain is always all real numbers for all parabolas or all quadratics. And the range. Y, because the parabola goes upward, we're talking about y is greater than or equal to, and it's whatever the y value of the vertex. So this one is the x value of the vertex for the axis of symmetry line. The range is always the y value of the vertex, whether it's up or down. Now it says use words like vertical stretch, vertical shrink, reflection to compare. Anytime you are timesing the x squared by a number, that is a vertical stretch or shrink. If the number is bigger than 1, that is a vertical stretch. If that number is smaller than 1, like a half, that would be considered a vertical shrink. Here's what that means. Notice I'm going to compare just this point, this point, meaning 1, 1 in the parent function, 1, 2 in the new function. Actually, I'm going to make two comparisons. This is 2, 8. This one's 2, 4. Notice it's twice as much vertically. So anytime the number in front of the x squared is bigger than 1, that is a vertical stretch of the graph. Next one. Now they already did the parent function, so I didn't have to do it again. Let's do an XY chart. There's not a lot of space again. Let's do an XY chart for this particular graph. So I'm going to do the same numbers I just did. 2, 1, 0, -1, and -2. So if I plug 2 in, 2 squared times -1/2. So 2 squared is 4 times -1/2 would be -2. 1 squared is 1 times -2 is -1/2. And 0 squared. -1 would also be -1/2. And -2 would also be -2. Graph. And this one's going to be hard to see. Sometimes it's better to actually do a number that's a little further away, like -4 and 4. That gives a better picture of the graph. So if I put 4 squared times -1/2, I'd get -8. So again, adding some more XY points is never a bad thing. I'm going to graph this. 2, -2, 1, -1/2, 0, -1/2. And then I did 4, -8. So again, just did an extra point there to kind of get my picture a little bit better. All right. Vertex. Vertex would be at the point 0, 0. It's the highest point of the picture. We got x equals 0 again. The y-intercept is when you put 0, or when does it cross or touch the y-axis? So again, the y-intercept is where it touches the y-axis. Not a big fan of that question, to be honest with you. Domain, all real numbers. And now y is less than or equal to 0. So again, the axis of symmetry is always the x value as a line. The range is always the y value of the vertex as an inequality, whether it's up or down. Now, two things happen here in a comparison point. First of all, it flipped and went downward instead of upward. That negative sign that's in front of the equation, that is a reflection on the x-axis. Now, some people would just say reflection. Again, I am wanting you to say reflection on the x-axis because you actually can have a reflection on the y-axis. We won't do that necessarily in this class, but later on you will. So again, I want to be specific that that negative sign is a reflection on the x-axis. Now, we talked about this in the previous slide. This half, anytime you're multiplying the x squared by a number, it's either a vertical stretch or vertical shrink. In this case, it's a vertical shrink because the number you're multiplying by is between 0 and 1. So it's below 1. therefore causing a vertical shrink. Just a comparison, this is the point 2, -2, and this is the point 2, 4. So it's half as much towards the x-axis. So that is called a vertical shrink. Parent function still sitting off to the side. Here we go. Vertex, I'm still going to do the same XY chart for right now. I'm still going to do -2. So if I plug 2 squared, you square before the negative, by the way. So it's 2 squared times negative, which would be -4, plus 5. 1 squared, which is 1, times the negative. 0 squared, negative, plus 5. -1 squared. Now that's a positive 1 times the negative that's in front of the x squared, plus 5. And then -2 squared times the negative, plus 5. So I'm going to graph these. 0, 5, 1, 4, -2, 1. So now notice that the parabola goes downward. Vertex is at 0, 5. Axis of symmetry is x equals 0. Range, y would be less than or equal to 5, and they're all real numbers. Now the y-intercept is at 0, 5 as well. All day today, I believe all of your y-intercepts will kind of match your vertex, which is kind of unfortunate because that's not true all the time, but for today it's going to look that way. All right. Anytime you add or subtract a number to the parabola, you are talking a translation. So now you are actually, this plus 5 is a translation up 5. So notice anytime you're adding a number, it's going to be a translation up. Anytime you're subtracting a number, it's going to be a translation down. Now, you're not multiplying by anything, but you do have a negative sign. So that means something. We talked about that on the previous slide. It's a reflection on the x-axis. Next one. And again, not a lot of space here. I'm going to go ahead and do my XY chart. I think this might be a better location for my XY chart. So I'm going to go 2 to -2. So I'm going to plug 2 squared minus 3, 1 squared minus 3, 0 squared minus 3. Now, -1 squared is a positive, minus 3. And then 2 squared, -2 squared, which is 4, minus 3. So I'm going to graph those points. So I've got 0, -3, 1, -2, 2, 1. Same on the other side. So there's my parabola. Vertex is at 0, -3. Axis of symmetry is the x value, so x equals 0. The range is y is greater than or equal to -3. Again, the parabola goes upward. All real numbers. And again, the misleading question, I think the y-intercept is at 0, -3. All right. Because the vertex, the translation describes where the vertex is located. The vertex went down 3. So we're talking about a translation down 3. So again, translations describe the vertex. So wherever the vertex is located, that's what the translation is. So again, the parent function is at 0, 0. So we're talking about a translation down 3. And then there's nothing else. Nothing means multiplied by the x squared, so therefore there is no vertical stretch, there is no vertical shrink, there's no negative sign in front, so there is no reflection. Here's a chart that you may want to print or you may want to look at or circle. This basically describes all the different, when's it a vertical shrink, when is it a reflection, and so on. So if the a value that you're multiplying by in front of the x squared is bigger than 1, that is a vertical stretch. If the number is between 0 and 1, that is a vertical shrink. So whatever number is being multiplied in front of x squared, if there is no number in front, then there is no vertical stretch and there is no vertical shrink. If there's a negative now in front, And I don't like that they put these together, but if there's a negative in front, that is a reflection on the x-axis. So you don't need to know anything else. If there's a negative, you don't need to any of that other green stuff. You would just say reflection on x-axis. So if it is multiplying by a negative, notice that they put, if it's below 1 and negative, it's a vertical stretch and a reflection. If it's between -1 and 0, it's a vertical shrink and a reflection. I consider those to be two separate things, multiplying by a number and then having a negative. And then if you add a number to the function, that is a translation up, whatever that happens to be. If you subtract a number, that is a vertical translation down. So again, that describes where the vertex is going to be located. Next, we're moving on a little bit to 8.2. We're talking about zeros and x-intercepts. So now, these all kind of describe the same thing. So this is a little bit misleading. A zero is the x value for the function equaling 0. Now, it is also the location of the x-intercepts. The x-intercept is truly the points where the graph crosses or touches the x-axis. They consider that to be the x-intercept. And the roots is the solution. Now, this is also the location of the x-intercepts. So they kind of all go together, which does make this a little bit interesting. Graph the function, then identify the zeros. Check your solution by using algebra, so factoring. Let's first graph it. I'm going to make an XY chart. And I'm going to go a little bit bigger, and some of you might say, well, why did you decide to go bigger on this one? You'll see why in just a second. So I'm going to plug in, and I probably should have went in the other order. 3, 2, 1, 0, -1, -2, -3. So if I plug in 3, I get 0. 2, -5. 1, -8. And then plugging in the negatives. Remember, when you square a negative, it's back to positive. So -1 squared minus 9. So I'm going to graph all of those points over here. So 3, 0, 0, 9. So looking at the graph, I see two x-intercepts. I see the point 3, 0. I see the point -3, 0. And so when I ask for, those are the x-intercepts. If I then ask for the zeros of the function, now you're saying that x equals -3 and x equals +3. So those are the locations where the x causes the function to be 0. Now, they wanted me to do this algebraically, meaning they wanted me to put 0 in for the function and solve. So this is the location in which f of x equals 0. Going back to last chapter, this is factorable. Set the parentheses, equal to 0, and solve. So what we're trying to get at here is if I can graph it and I can find the location where it touches or crosses the x-axis, I then can state the solutions just by looking at the graph. So sometimes when you're graphing, you can see where it's crossing the x-axis. That would also then allow you to find the zeros. Graph the function. Now, I'm going to go ahead and hit pause here and give you an opportunity to do this one by yourself. All right, welcome back. So here we go. We're going to make an XY chart. I'm going to put in 2. So 2 squared is 4, times -3 is -12, plus 9 would be -3. 1 squared times -3 plus 9, -1 squared. So I'm going to graph these points. So 0, 9, 1, 6, and that's the same on the other side. Whoops, I totally apologize here. 0, 9 was up here. Went the other direction. 1, 6, and then 2, -3. So I apologize for that. So there is. Now, when I ask you to compare, I want you to use your vocabulary. So notice there's a negative sign out in front. So that is a reflection on the x-axis. I then see a 3 in front. That is a vertical stretch by 3. And then the plus 9 causes a translation up 9. Next, find the zeros of the function using algebra. So I want to use algebra to find the zeros. It has a GCF. Remember, that's always the first thing I look for. Continue to factor, difference of squares, and then solving. Solving, I set these factors equal to 0. So x is equal to -2, and x is equal to +2. So that goes back to last chapter. Your homework assignment, going all the way back to the front page, your homework assignment is a worksheet. If you have any questions, please make sure that you talk to your teacher, and good luck.